Welcome students. Today we will discuss the third part of the numericals of lesson number 2 of class 12th, that is solution. In this section we will study the numericals based on Raoult's law. First of all, we will see what is Raoult's law and then we will discuss its numericals. First of all, as we study Raoult's law for a solution containing non-volatile solute. To understand Raoult's law for such type of solution, I have shown here two diagrams. In the first diagram, I have shown one vessel containing pure solvent, pure liquid, that is shown by green color. Above to the surface of liquid, there is vapor of the liquid collected. This vapor exert vapor pressure, that is P naught A. P naught A represent vapor pressure of pure solvent. Now see the another diagram. In this vessel, I have dissolved a non-volatile solute in the pure solvent and I have converted it into solution. As a result, some part of the surface of liquid is occupied by the non-volatile molecules of solute. They prevent the escaping of solvent molecule into the vapor state, and therefore the amount of vapor formed at the surface of liquid will be decreased, and therefore the vapor pressure will also be decreased. P naught A is the vapor pressure of pure solvent. Pa is the vapor pressure of solution containing non-volatile solute, that is shown by pink colored dots. The value of Pa is less than P naught A. Why? Because while making the solution of non-volatile solute in the solvent, a fraction of surface of the liquid is occupied by non-volatile molecule of the solute. They prevent vaporization. That's why the amount of vapor formed at the surface of liquid will be decreased. So the vapor pressure of solution containing non-volatile solute will be always less than the vapor pressure of pure solvent. According to Raoult's law, the vapor pressure of solution, that is Pa, is directly proportional to the mole fraction of solvent in it. Once again, according to Raoult's law tell you the quantitative relationship of the lowering of vapor pressure when you dissolve a non-volatile solute in the solvent. So after dissolving non-volatile solute in the solvent, the vapor pressure of solution is directly proportional to the mole fraction of solvent remaining in it. This is the Raoult's law. If you convert the sign of proportionality into equal to, you have to place a constant. So we can write the equation Pa equals to P naught A into XA. This is the mathematical expression for the Raoult's law. Pa equals to P naught A into XA, where P naught A is the constant of proportionality and it is representing the vapor pressure of pure solvent, pure liquid, whereas Pa represent the vapor pressure of solution. XA is the mole fraction of solvent in the solution. In this equation, Pa and P naught A must be used in same unit. If Pa is in bar, then P naught A should also be in bar. For a solution containing only two components, one is A that is solvent, another is B that is solute, we can write the value of xa as 1 minus xb. When I put this value of xa in this equation, we can derive one another formula for the Raoult's law. See at the next page. Now, multiply P naught A into the component of bracket. So P naught A minus P naught A into XB, that equals to PA. On rearranging the equation, you will get a new equation, that is P naught A minus PA upon P naught A is equals to XB. This is one another equation used for the Raoult's law. Here P naught A minus PA represent lowering in vapor pressure, means after adding the non-volatile solute the vapor pressure is lowered. P naught is the vapor pressure of pure solvent and Pa is the vapor pressure of solution. Pa is less than P naught A, so P naught A minus Pa is representing lowering in vapor pressure, and P naught A minus Pa upon P naught A represent relative lowering in vapor pressure. So, as per this equation, we can say that relative lowering in vapor pressure for a solution containing non-volatile solute is equal to Xb, means mole fraction of solute. Once again, the relative lowering in vapor pressure for a solution containing non-volatile solute is equal to the mole fraction of solute in it. This is the another statement of Raoult's law. You can use any one of the equation, either this equation or this equation, for the numerical purpose. Any one equation can be used, you will get the same results. Now, the Raoult's law for a solution containing two or more volatile liquids. A solution containing two or more volatile liquids. To understand this Raoult's law, again I made one vessel containing two liquids. One is shown by the green color, another is shown by the pink color. Both of these liquids are volatile, so both will be vaporized to give their vapor. Above the liquid surface, there are vapor of both the component. Now, suppose the vapor pressure of the A component in the pure state is suppose P naught A, and the vapor pressure of A component in the solution is suppose PA, then PA will be less than P naught A. Similarly, if P naught B is the vapor pressure of B component in the pure state and PB is the vapor pressure of B component in the solution, then PB will be less than P naught B, and PA will be proportional to XA, whereas PB will be proportional to XB. This is the Raoult's law for the solution containing two or more volatile liquids. Means the partial vapor pressure of a component in the solution of two or more volatile liquids will be directly proportional to the mole fraction of that component. So Pa is directly proportional to Xa and Pb is directly proportional to Xb. If you convert sign of proportionality into equal to, you have to place constant of proportionality. So Pa become equal to P naught A into Xa, whereas Pb become equal to P naught B into Xb. Once again, I want to explain you. When you take a solution containing two or more volatile liquids, suppose A and B both are volatile liquid, if their vapor pressure in the pure state are P naught A and P naught B respectively, and their vapor pressure in the solution are Pa and Pb respectively, then Pa will be less than P naught A and Pb will be less than P naught B. And according to Raoult's law, Pa will be directly proportional to Xa and Pb will be directly proportional to Xb, because the partial vapor pressure of a component in the solution of two or more volatile liquid will be directly proportional to the mole fraction of that component. When you convert sign of proportionality into equal to, you have to place constant, and these constant are the vapor pressure of pure solvents. So Pa is equals to P naught A into Xa and Pb equals to P naught B into Xb. The total vapor pressure, that will be equal to summation of Pa and Pb. So it will be equal to P naught A into Xa plus P naught B into Xb. Here in the question, P naught A, P naught B and the data related to get the value of Xa and Xb will be provided, and P total may be asked to calculate. So very simple question are asked on this formula. Here P total, P naught A, P naught B must be in the same unit. Now let us see some important numericals based on Raoult's law. First of all, we will discuss the example of the solution containing non-volatile solute, and then we will discuss the example of solution containing two or more volatile liquids. The first numerical related with Raoult's law is 2 gram glucose is dissolved in 88 gram of water. Find vapor pressure of this solution. Vapor pressure of pure water is 12.3 kilopascal at the 300 Kelvin. This is provided. So I will take the equation P naught A minus Pa upon P naught A equals to Xb to solve this numerical. Now what is Xb? Xb is ratio of number of mole of solute upon total number of moles present in the solution. Here masses are given, so convert each type of mole into mass. So we'll get equation Wb by Mb upon Wa by Ma plus Wb by Mb. So P naught A minus Pa upon P naught A is equals to Wb by Mb upon Wa by Ma plus Wb by Mb. This formula will be utilized here to solve the numerical. Now what things are given here? We have been provided here Wb, that is 2 gram, that is the mass of solute. Glucose is here solute and its 2 gram is given here. Then WA is provided, that is 88 gram. WA is the mass of solvent and here the solvent is water. It's 88 gram are given here. So P naught A, that is the vapor pressure of pure solvent, that is also provided here for the water, that is 12.3 kilopascal. And we have to determine the value of PA, that is the vapor pressure of this solution. Molar mass of solvent Ma is 18 gram per mole. This is the molar mass for water. Water is solvent here. And molar mass of solute Mb is 180, as the solute is glucose here. The formula of glucose is C6H12O6. If you find the molar mass for this C6H12O6, you will get 180 gram per mole. So everything is given. We have to determine the value of PA. Now put value of all things in this formula. So PA, we have to determine P naught A is given here 12.3 kilopascal. Keep in mind, if you are using P naught A in kilopascal, then PA will also be determined in kilopascal. PA we have to calculate. So 12.3 minus PA upon again 12.3 for the P naught A value is equals to WB is here 2, MB here is here 180, WA is here 88, MA is here 18, WB again 2, MB is again 180. When you will solve it, you will get the value of PA, and that is 12.271 kilopascal. I have already told you, if P naught A is taken in kilopascal, then PA will also be in kilopascal. So in this way you will solve it. So it is very easy numerical, everything is given, but mole fraction directly is not given here. In place of mole fraction, masses are given. So I have converted XB into NB upon NA plus NB. Then each one NB and NA is converted to mass. So we are getting here formula P naught A minus PA upon P naught A equals to WB by MB upon WA by MA plus WB by MB. Here PA is asked, P naught A is given, WB is given, WA is given, MA, MB you can easily calculate on the basis of the formula of solvent and solute. So it is very easy numerical. Put all these values, you will get the calculate the value of PA, and its unit is kilopascal. That's all. Now the next numerical related with the Raoult's law. An aqueous solution of 5% non-volatile solute exert a pressure of 0.976 bar at the normal boiling point of solvent. What is the molar mass of the solute? So once again I will use the same equation, that is P naught A minus PA upon P naught A is equals to XB. Now what things are given here? Make the list of all given items in the question. Here the vapor pressure of solution is given, means Pa is given, that is 0.976, the unit is bar. Okay, the value of P naught A, means pure solvent's vapor pressure, is not given. In place of this, the condition of the solution is given here, that is the normal boiling point of the solvent. If you are doing experiment at the normal boiling point of the solvent, then definitely the vapor pressure of solvent will be equal to the atmospheric pressure, and that's why the value of P naught A must be 1 atm, that is a atmospheric pressure. It is not given the question, but you have to see what should be the value of P naught A. The condition of the experimentation is given normal boiling point of the solvent. At the boiling point, the vapor pressure of a liquid become equal to atmospheric pressure. That's why here we will take the value of P naught A as 1 atm. So P naught A is 1 atm. You have to convert it into bar as Pa is given in bar. So this is 1.01325 bar. 1 atm is equals to 1.01325 bar. In place of mole fraction of solute, there is mass percentage of solute given. Mass percentage is actually equal to Wb upon Wa plus Wb into 100. If we assume here Wa plus Wb equals to 100 gram, then Wb will be equals to mass percentage, and that is here 5 gram. Mass percentage is given here 5%. So if you take solution as 100 gram, then the Wb means mass of solute will be equals to mass percentage, so its value will be 5 gram. So what will be Wa here? That is 100 minus 5 means 95 gram. As usual, the Ma means molar mass of solvent is 18, because the solvent is again here water, the solution is aqueous, so the molar mass is 18 gram per mole for the solvent, and Mb you have to determine. So I've recorded here what things are given as per the question. Now P naught A minus Pa upon P naught A is equals to Xb, and Xb is equals to Nb upon Na plus Nb, and that is equals to Wb by Mb upon Wa by Ma plus Wb by Mb. Whenever a solution is dilute, we can ignore the value of Wb by Mb in the denominator, because the value of Wa upon Ma is larger than Wb upon Mb, so we can neglect the value of Wb upon Mb in the denominator. So if you neglect Wb by Mb in the denominator, we will get equation P naught A minus Pa upon P naught A equals to WB by MB upon WA by MA. On solving, it becomes WB by MB into MA upon WA, and that is equals to P naught A minus PA upon P naught A. Now put all values given and calculate the value of MB. P naught A is here 1.01325 bar, that is the atmospheric pressure, minus PA. PA is given 0.976 bar. Once again upon P naught A 1.01325 bar. WB we have extracted from the value of mass percentage given, that is 5 gram. Molar mass MB we have to determine. MA is 18 for the water and WA is 95. So we have put all these value and now calculate the value of MB. So MB will be here determined as 25.7697 gram per mole on solving. So the molar mass of the substance dissolved in water is 25.7697 gram per mole. This is the final answer. That's all. Now our next question. Find vapor pressure of 1.5 molar solution of a non-volatile solute, molar mass of which is 60, that is dissolved in benzene at 300 Kelvin. Vapor pressure of benzene is 0.850 bar at the 300 Kelvin. So once again we will use the same equation, that is P naught A minus PA upon P naught A is equals to XB. Now what things are given here? We'll record it at the right side. At this time P naught A, that is the vapor pressure of pure solvent, that is benzene, is given here 0.850 bar, and we have to determine here PA, means vapor pressure of solution. In place of XP again there is something different is given, that is molarity. Molarity of the solution is provided, that is 1.5 m. We have to get the required information from this molarity. How? Molarity is equals to number of mole of solute Nb upon mass of solvent in kilogram. Suppose Wa is 1 kg. Suppose the solution contains 1 kg of the solvent, then as per this equation Nb become equal to molarity and its value is 1.5, so Nb become 1.5 mole. So we have determined the value of Nb, and the value of Wa is 1 kg. So what is Na? Na is Wa by Ma. Wa we have assumed in the solution as 1 kg means 1000 gram upon molar mass of water is here the solvent is benzene, so molar mass of benzene will be here 78. So 1000 upon 78 is the number of mole of solvent present here. On solving you will get here 12.82 mole. Now Once again, see this equation: P naught A minus PA upon P naught equals to XB. XB is equals to NB upon NA plus NB. Now we know all the things here except the PA. So put all the values in this equation, calculate the value of PA. P naught A is here provided 0.850. PA you have to determine. P naught A is again 0.850 equals to NB. NB is 1.5. NA, NA you have determined 12.82. NB is again 1.5. On solving, it is 1.5 upon 14.32, and that is equals to 0.850 minus PA upon 0.850. When you solve it completely, you'll get the value of PA as 0.7610 bar. P naught is here in bar, so PA will also be determined in bar. So this is your final answer. That's all. Now the next problem, that is related with Raoult's law for a solution containing two or more volatile liquids. The question is, find total vapor pressure of an ideal solution prepared by mixing 78 gram benzene into 184 gram toluene. I will consider as the benzene as A and the toluene as B. Okay, so 78 gram benzene is dissolved into 184 gram of toluene. I will take benzene as A and toluene as B. The vapor pressure of pure benzene is given here 50.71 mm of Hg, and pure toluene is given 32.06 mm of Hg. So we have to determine first the total vapor pressure of the solution, and after that we have to determine mole fraction of benzene and toluene vapor phase above the solution at 300 Kelvin. So what things are given here? For benzene, P naught A is given, that is 50.71 mm of Hg. Then its mass is given, means WA is given, that is 78 gram. Molar mass of benzene means Ma is also 78 gram per mole. Now come to what thing are given for toluene. For toluene, to which I am taking symbol B. P naught B is given 32.06 mm Hg. WB is given 184 gram. MB, the molar mass of toluene, this is 92 gram per mole. You should know the formula of benzene and toluene. The formula of benzene is C6H6, whereas for toluene it is C6H5CH3. Okay, so using these formula we have determined the value of their molar masses. Now first of all we will determine the number of mole of each component in the solution. So Na is Wa by Ma. Wa is given 78. Ma is also 78. So it is 1 mole. Similarly Nb. Nb is Wb by Mb. Wb as per the question is 184 and Mb for the toluene is 92. Solving it you will get 2 mole. Now we'll determine mole fraction of each component. So Xa, that is equals to Na upon Na plus Nb. Na is 1, Na is 1, Nb is 2. So it is 1 by 3. Xa is 1 by 3. Similarly Xb, we have two ways to determine the Xb. Either subtract Xa by 1 because the sum of Xa and Xb will be equal to 1. So 1 minus Xa is equals to Xb. Or you can use the same formula as the Xa, that will be Nb upon Na plus Nb. Whatever you can use. So 1 minus Xa is 1 minus 1 by 3. So it is 2 by 3. Now use the equation in which you will put all the values and will calculate the total vapor pressure caused by both the component of the solution. It is denoted by P total, and P total is equals to PA, that is vapor pressure of A component, plus PB, that is vapor pressure of B component, and PA will be equals to P naught A into XA, and PB will be equals to P naught B into XB. Now we have all values. P naught A is 50.71 for benzene in the unit mm of Hg. Its mole fraction is 1 by 3. And P naught B is 32.06 for toluene. Unit is mm of Hg, and its mole fraction is 2 by 3. So this, on solving, you are getting 16.9033, and this on solving you will get 21.3733. So you will get P total as 38.2766 millimeter of Hg. This is your first answer. The total vapor pressure exerted by both the component of this solution will be here 38.2766 millimeter of Hg. How we have determined? This total vapor pressure will be equal to the sum of Pa and Pb, where Pa is the vapor pressure of component A and Pb is the vapor pressure of component B in the solution. Pa will be equals to P naught into Xa, and Pb will be equals to P naught B into Xb. We have put the value of P naught A and Xa, P naught B and Xb, and calculated the value of P total, that is 38.2766 millimeter of Hg. So this is our first answer. Now the second part of the question. Also determine mole fraction of benzene and toluene in vapor phase above the solution at 300 Kelvin. Means आपको vapor pressure की हेल्प से बेंजीन और टॉलिन के वेपर फेज में कंपोजिशन भी निकालना है. मोल फ्रैक्शन ऑफ द बेंजीन टॉलिन इन द वेपर फेज. So how to calculate the vapor pressure, uh, mole fraction in the vapor phase? To get the values of mole fraction in the vapor phase, we have to take help of Dalton's partial pressure law, which you have studied in the class 11th in the chapter states of matter, chapter number 5. According to Dalton's partial pressure law, PA will be equals to P total into XA. Sorry, mole fraction the vapor phase, suppose it is YA. According to Dalton's partial pressure law, the vapor pressure of a component in a mixture of gases will be equal to total pressure of all the component multiplied with the mole fraction of that component in the vapor phase. So Pa is equals to P total into Ya, where Pa is the vapor pressure of A component, P total is the vapor pressure of both the component, and Ya is the mole fraction of A component in the vapor phase. Using this formula, we will determine the value of Ya. The vapor pressure of A component we have determined as P naught into Xa, and its value is 16.9033 that we have already determined, and P total we have determined 38.2766. I want to show you where we have calculated the value of Pa. See this value, Pa is equals to P naught A into Xa. We have determined this value as 16.9033. Similarly, PV is equals to P naught P into XB, and that value is 21.3733. So we have determined it. So PA is 16.9033 and P total we have determined 38.2766 into YA. So on solving, YA will be obtained as 0.4416, and YB, that is the mole fraction of B component in the vapor phase, that can be determined by 1 minus YA, as the sum of YA and YB will be here 1. So this will be 50, sorry, this will be 0.5584. We can determine the value of YB using this formula also. PB is equals to P total into YB, where PB will take 21.3733 and P total we take 38.2766 into YB. Here also you'll get the same value of YB, that is 0.5584. So these are the mole fraction of A and B component in the vapor phase. वेपर फेज में मोल फ्रैक्शंस डाल्टन्स पार्शियल प्रेशर लॉ के एप्लीकेशन से निकलते हैं. सो दिस इज ऑल अबाउट द यूज ऑफ फॉर्मूला related with the Raoult's law for a solution containing two or more volatile liquid. This example is enough. Okay, for the practice you can solve some more questions, but for the conceptual point of view this example is enough. So this is all about the Raoult. So thanking you